Hello, dear students. Good morning. We already completed 5 chapters: Chapter 1, Chapter 2, Chapter 3, Chapter 4, and Chapter 6. Chapter 7 we will study later. That's for the next term only. So, let's start 8th chapter, Quadrilaterals. Yes, quadrilateral is not a new term for you, dear children. All of you know what is a quadrilateral. Can you remember? Yes. A quadrilateral is a four-sided polygon. Four-sided polygon means there are different types of quadrilaterals. For example, yes, a four-sided polygon, a rectangle. Next, a four-sided polygon, a parallelogram. Next, also a four-sided polygon, trapezium. A four-sided polygon, a square. Okay. A four-sided polygon, rhombus. That is, yes, now you can see there are different types of quadrilaterals. Yes, from this what we can tell, these all having different properties. That's why we are calling them differently. Yes, this first one is a rectangle. Yes, this one is a rectangle. Then this one is a parallelogram. Then this one is a trapezium. Yes, this already know. This is square. This one is a rhombus. Okay. In this chapter, we are going to study some theorems. That is, we already learned that in lower classes. That time we didn't prove that. Now we are going to study is a proof also. Okay. This chapter mainly focus the concept parallelogram. Yes. You know that parallelogram have different properties that you've already learned in lower classes. Then that all the properties we are going to study in the form of a theorem and its proof. Okay. Yes. Properties of a parallelogram. Yeah, dear children, while thinking properties of parallelogram, yes, a parallelogram is a four-sided polygon, and we know that its opposite sides are equal, opposite angles are equal, its diagonals bisect each other, and adjacent angles are supplementary. Okay, then among these all, first we have to understand that in a parallelogram, opposite sides are parallel. Opposite sides are parallel. Yes, while naming, if the sides A, B, C, D, what we can tell AB parallel to CD and AD parallel to BC. Two pair of parallel sides. Yes, that's the first property of this parallelogram. Then while thinking this rectangle, what we can tell? Yes, if P, Q are S, four vertices, PQRS, then what you can tell? PQ equal to RS and PS equal to QR. Opposite angles are equal and all angles are of equal measure. First what we can tell? Opposite sides are equal. PQ equal to RS and PS equal to QR. Is a rectangle a parallelogram? Yeah, very sure that. Because in a rectangle, opposite sides are parallel and equal. Next, trapezium. Okay, if the name PSTV, what we can tell? Trapezium is one pair of parallel side. PS parallel to VT, but PV not parallel to ST. Trapezium is a quadrilateral having one pair of parallel side. Okay, next square. MNOP. We all know that in a square, four sides are equal. MN equal to NO equal to OP equal to PM. Next, rhombus. EFGH. Rhombus means all the four sides are equal. EF equal to EFG equal to GH equal to EH. Not only that one, a rhombus is a parallelogram whose four sides are equal. EF parallel to GH, EH parallel to FG. Okay. Yes, these are the main concepts. I've already told that this chapter focusing only parallelogram. Okay. Yes. Yes. First, we've already discussed different types of quadrilateral, and for these all the quadrilateral, a common property is there. Yes, what is that? Yes, we've already discussed different quadrilaterals there. Then a common property is there for every quadrilaterals that we can study now. Okay, I consider one quadrilateral. Its name ABCD. Okay, you know that for a quadrilateral we can draw two diagonals. Yes, I am considering only one diagonal. AC is its diagonal. Yes, the diagonal AC divides into two triangles. The diagonal AC divides the given parallelogram into two triangles. First triangle and the second triangle. We all know that sum of angles in a triangle equal to 180. Yes, that we can write now. Yes. For the first triangle ABC, what we can tell? Sum of angles equal to 180. That is, there are three different angles. 1, 2, 3. The sum of these three angles equal to 180. Then what we can write? Angle BAC plus angle ACB plus angle B equal to 180 degree. Because these are the three angles in the triangle ABC. Then we can give equation number 1. Then while considering the next triangle ADC, yes, there also you can see three angles. 1, 2 and 3. Then what we can tell? Angle CAD plus angle ADC plus angle ACD equal to 180. That is equation number 2. Now we got two equations. First one is angle BAC plus angle ACB plus angle B equal to 180. That is for the first triangle ABC. Then for the second triangle ADC, angle CAD plus angle ADC plus angle ACD equal to 180. Okay. Then add equation 1 and 2. One plus 2. While adding two equations, you have to add LHS first, LHS of the first equation and LHS of the second equation. Yes. What are the LHS? Angle BAC plus angle ACB plus angle B. For the first equation, angle BAC plus angle BCA plus angle B, that is LHS of the first equation, plus then LHS of the second equation. Angle CAD plus angle ADC plus angle ACD equal to, we added LHS. Same way we had to add RHS. Then RHS of the first equation 180 plus RHS of the second equation also 180. So 180 plus 180 equal to 360. Here we can consider that equal to 360. Then in the figure, angle BAC plus angle CAD. See here. Angle BAC plus angle CAD. This is angle BAC. This one is angle CAD. While adding BAC and CAD, we will get a total angle BAD. While adding these two, we will get a total BAD. That is, instead of BAC plus CAD, we can write a BAD. Okay. While adding which, yes, one more time, BAC plus CAD. Yes, BAC. This BAC and CAD, while adding, you will get BA. Yes, here is a. While adding these two, you will get BAD. That is, instead of these two, while adding, we can write angle BAD plus angle BCA and angle ADC. Okay. Angle BCA. Yes. Which one is BCA? This one. BCA plus ADC. BCA plus ACD. Okay. BCA plus ACD. BCA plus ACD gives this total angle. Which one? BCA. And this ACD, while adding, you will get a total angle of BCD. Okay. We added this BCA and ACD. BCA and ACD, while adding, you will get a total of BCD. Then angle B. Yes, same angle B. ADC, angle ADC, this one, this angle ADC, we can write. Yes, and which one is angle ADC here? ADC means same as angle D. ADC is same as angle D. Angle D equal to this 180 plus 180 equal to 360. Okay. Then angle BAD. Yes, in the figure, angle BAD means that is same as angle A. We can represent angle by 3 letters or 1 letter. So this one is same as angle A. Same way angle BCD. Angle BCD, we can represent that by angle C. Next, angle B already there. Angle B plus, then angle D equal to 360. That is what we can tell here. Angle A plus angle C plus angle B plus angle D equal to 360. For our convenience, we can write angle A plus angle B plus angle C plus angle D equal to 360. Yes. This is the very important property of the quadrilateral. That is, for every quadrilateral, sum of angles in a quadrilateral equal to 360. This is not only for the parallelogram, for every quadrilateral. For every quadrilateral, sum of angles in a quadrilateral equal to 360. That is known as angle sum property of quadrilateral. First we have to study that one. That is, sum of angles in a quadrilaterals equal to 360 degree. That is known as angles of property. Okay. Next is different types of quadrilateral and its properties we've already discussed. Next, we have to study properties of parallelogram. I've already told you all the properties we are going to study in the form of theorem and its proof. In this chapter, there are total 8 theorems. Okay, what's the first one? A diagonal of a parallelogram divides it into two congruent triangles. A diagonal of a parallelogram divides it into two congruent triangles. Yes, congruent triangles. You've already studied in lower classes. For two triangles, there are different congruence rules. Can you remember? SAS, SSS, ASA, like there's so many. Actually, dear children, in 9th standard, you have to study more congruence rule, that is in 7th chapter. But the problem here is 7th chapter is for the next term only. So without studying that chapter, it is somewhat difficult to study the 8th chapter. Because all the congruence rule what we studied in 7th chapter we have to use here. Okay, while doing each theorem, I will explain that one. I think that then you can understand. First one is, first theorem. A diagonal of a parallelogram divides it into two congruent triangles. Okay. Yes, first of all, we can start from a parallelogram. Let's say parallelogram ABCD. Yes, then we have to prove that the diagonal. So we have to draw a diagonal. Diagonal means the line segment joining two non-adjacent vertices. Here A and C. Okay, AC is a diagonal. We have to prove that the diagonal AC divides the parallelogram into two congruent triangles. We already know that a diagonal divides into two triangles. But here we have to prove that not only triangles, they are congruent. Okay. Yes, dear children, ABCD is a parallelogram means we know that AB is parallel to CD. AB is parallel to CD. AB and CD are two parallel lines. Yes, if AB and CD are parallel, we can consider AC as its transversal. AC is the transversal of these two parallel lines AB and CD. Okay. Then, in the chapter Lines and Angles, we already studied that for the parallel lines and its transversal, alternate interior angles are equal. Yes, here consider alternate interior angles. Yes, these two angles. That means angle BAC equal to angle ACD. Okay. And it is given that ABCD is a parallelogram. So AB is parallel to CD. Not only that one, AB equal to CD also. And AD equal to BC also. Then while considering the diagonal AC and AB and CD are parallel, we will consider AC is the transversal. So alternate interior angles are equal. Same way, one pair of alternate interior angles equal, we can mark one more pair of alternate interior angles. Yes, that is AD. When AD and BC are parallel, this AD and BC are parallel. Same way we can consider AC is its transversal. AD and BC, two parallel lines, and AC is transversal. Then here also alternate interior angles. You can see alternate interior angles, that is these two. These two alternate interior angles are equal because AD parallel to BC, AC is transversal. So angle DAC equal to angle ACB. Yes. Now we are going to prove this triangle ABC is congruent to triangle CDA. Yes, listen dear children. In two triangles ABC, one triangle, first triangle ABC I considered. Then in triangle ABC and this first triangle and second triangle ABC, and in the second triangle, in the first triangle A, that means A angle A of the first triangle and angle C of the second triangle are equal. So ABC and consider angle C. And we know that this is ABCD is a parallelogram. In parallelogram, opposite angles are equal. Or yes, we can consider another way, that is angle C of first triangle and angle A of second triangle equal. Same way, angle A of first triangle and angle C of second triangle also equal. Then AC is the common side. AC is common for both triangle ABC and ADC. That is, these two angles equal, this also equal. That is, two angles and one side is common. Two angle and one side is common means there is a congruence rule, ASA. Two angle and one side. That is, you didn't study the last chapter, 7th chapter, so it is somewhat difficult, dear children. Anyway, listen here. In two triangles, corresponding angles are equal. That means this angle A and this marked angle, that is white marked angles. These two angles equal. Same way, next one more pair of angles equal. So two pairs of angles and its side, one side also equal. That one side is common for that two angle. So by using ASA congruence rule, what we can tell? Why ASA means two angles and a side. That side, listen dear children. Here, while considering the side, you have to understand that one. That side is side, that means this side means AC is common. Okay. Yes, that two angles are on the both side of the side AC. So we can consider another side AD or BC. That means, yes, while considering the angles, that angle should be in the ends of that side. Okay. Then by using ASA congruence rule, we can tell that triangle ADC, triangle ADC, triangle ADC, yes, you know this, the symbol of congruence, congruent to. Then in triangle ADC, first we consider the angle A. For the angle A, which angle is equal, which is the equal angle in triangle 2, that is C. Yes. Then C, D, angle AD, angle ADC. So the angle AB, ADC considered. Angle ADC consider congruent to angle CBA. Angle ADC congruent to angle CBA. we proved that two triangles are congruent. To prove that they are congruent, first we consider that pair of equal angles and a common side. So by ASA congruence rule, triangle ADC, then to find out the congruent, that means that's the corresponding side or corresponding angle. For the angle A, that means in the second triangle CDA, that is equal to angle BCA of the first triangle. So while starting from A of the second triangle, you have to start C of the first triangle because they are equal. Then for the angle D and angle B, we know that opposite angles are equal. So ADC congruent to, then angle D here means the next corresponding for D, it is B. That is ADC, triangle ADC congruent to triangle CBA. Okay. Next time, in a parallelogram, opposite sides are equal. Yes, that is here. Actually, dear children, in a parallelogram, we have to prove opposite sides are equal. In the last theorem, we already studied that these two triangles are congruent. That is, diagonal divides the triangle into two congruent parts. Yes, congruent means, okay, if ADC congruent to CBA, AD will be equal to BC or CB. ADC congruent means not only angles, its sides also equal. Triangle ADC congruent to triangle CBA means what we can tell, side AD equal to side CB. Here AD and BC are equal. Same way, yes. If ADC congruent CBA, we got opposite sides are equal. AD equals CBA. AD equal to CB. Same way, if we considered which one? Diagonal BD, we can prove that AB equal to DC. Okay. That's why no need of proof. No need of proof. Next one. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. In a quadrilateral, if each pair of opposite sides is equal, then it will be a parallelogram. Okay. Yes. It is not given that it is a parallelogram. It is not a parallelogram. Suppose that it is a quadrilateral only. Then it's a side PQ one side, then PQRS. Then here also we can consider a diagonal PR. Yes, it is given that if opposite sides are equal. So PQ equal to RS. It is given PQ equal to RS. Same way PS equal to QR. Then we have to prove that it is a parallelogram. Listen dear children, here also we can see two triangles 1 and 2. In the two triangles, yes, PQ equal to SR or PQ equal to RS. That means side equal. Yes, in both triangle, one pair of equal side, and again PS equal to QR. Again to one more pair equal, and PR is a common side. Then for the triangle PQR and RSP, okay, PQ equal to RS. That is, it is given that PQ equal to RS and PQ equal to RS and PR equal, yes, here, see here, PR, that is PR is same as RP, PR is same as RP, PR and RP equal. Then here two pairs of opposite sides, that means these two are equal, PQ equal to RS and PR equal to RP, that is same one, common side. Not only that one, it is given that PS equal to QR, PS equal to QR. So by one congruous, three sides, that means three sides of one triangle equal to three sides of another triangle. That means by using SSS congruence rule, we can tell what triangle PQR, triangle PQR congruent to PQR congruent to RS, triangle RSP. Triangle PQR congruent to triangle RSP. Yes, that means in this quadrilateral, the diagonals divides into two congruent triangles. Yes, we already studied that in the parallelogram, the diagonals divides into two congruent triangle. Now we got in this quadrilateral, the diagonal divides the quadrilateral into two congruent triangles. So what we can tell, this quadrilateral is a parallelogram. Okay. Yes. If each pair of opposite sides are equal, then the quadrilateral will be a parallelogram. Then, next theorem, in a parallelogram, opposite angles are equal. In a parallelogram, opposite angles are equal. No need of prove that one, dear children. We already studied that in a parallelogram, the diagonals divides the parallelogram into two congruent triangles. Two congruent triangles means corresponding angles are equal. Next, in a quadrilateral, each pair of opposite angle is equal, then it is a parallelogram. That is same as. That is, if for every quadrilateral, any quadrilateral, if opposite angles are equal, then it will be a parallelogram. That is also, dear children, same way, if opposite sides are equal, then the quadrilateral is a parallelogram. Same way, we can tell if opposite angles are equal, then the quadrilateral is a parallelogram. Then next, the diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. That also we can, yes, if the parallelogram divides, if the diagonals of the parallelogram divides into two congruent triangles, yes. Same way, one more diagonal also divides into two congruent triangles. If it is so, we can tell then the diagonals are bisect each other. Diagonals of a parallelogram bisect each other. Bisect means divides into two equal parts. While doing problem, we can understand that more. The next, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Yes, okay. it is given that the diagonals bisect each other. Diagonals bisect means here the center, so the intersection point is O. Bisect each other means AO equal to OC. AO equal to OC. Same way OD equal to OB. Yes. Then what we have to prove? If the diagonals bisect each other, we have to prove this quadrilateral is a, then this quadrilateral is a parallelogram. Okay, dear children, here also we can use congruency rule. In triangle AOB and DOC, two triangles AOB, this one and this one, AOD and DOC, AO equal to OC, AO equal to OC, then OD equal to OB. That means a pair of opposites, pair of equal or corresponding sides equal. So side is side equal, and also we can see here vertically opposite angles. These two are vertically opposite angles, that also equal. Then what we can tell, triangle AOB congruent to triangle COD. Yes, triangle AOB congruent to triangle COD. Then what we can tell, these two triangles AOB and COD are congruent. Congruent means they are, there's angles equal, not only that one, sides also equal. Then we can understand that AB equal to CD. This AB and CD are equal. Okay. Yes, same way while considering the triangle AOB, these two, AOD and BOC, we can prove that two triangles equal or congruent. So AD equal to BC. Okay, that means we can understand that opposite sides are equal. If opposite sides are equal, and also we can prove that this alternate interior angles for AC, for the diagonal AC, these two are equal. Okay. Then we can, first of all, we can prove that this, if alternate interior equal for any quadrilateral, then that two sides are parallel. So AB parallel to DC. Then AB parallel to DC, same way for the next diagonal DB, what we can tell, these two angles also equal, alternate interior angles equal. So AD parallel to BC. We got AB parallel to DC and AD parallel to BC, and also AB equal to CD and AD equal to BC, means ABCD is a parallelogram. Okay, dear children, these are the theorems we have to study in this chapter. One more theorem that we will study later. Then using these all the theorem, we have to do some problems. Yes. Okay, dear children.